In example number 2, imagine a straight ladder leaning on a wall, into a wall, right? And what happens if if you don't have good grip on the floor, or the floor is a little bit slippery, or the person is too heavy or what, then the ladder, the bottom, is sliding away from the wall, right? And let's say we know how fast the bottom is sliding away from the wall. We want to know how fast the top of the ladder is dropping down. In other words, how fast you're going to fall down if you're on top of the ladder and the ladder is sliding away. Okay? Very, very practical example. You want to know how fast you're falling, don't you? So, here's the example. A 10-foot ladder rests against a vertical wall. Okay, the bottom of the ladder slides away from the wall at a rate of 1 foot per second. And here comes the question, how fast is the top of the ladder sliding down when its bottom is 6 feet away from the wall? Okay, typically related rate questions are very wordy, a lot to write, but also very important to start with a little sketch. Okay, so here's the floor, kind of slippery floor, and here's the wall, and let's say the ladder is leaning right on the top, and this is the bottom, like so, and then those are the steps. Okay, and a heavy dude is standing on top, we think, and L, the length is fixed, is 10 feet. That doesn't change. And what happened is the bottom is sliding away, and since this is x and this is y, the direction here dx dt, and dx dt is 1 foot per second. Okay, and at this point, this distance right there is 6 feet. And of course, the top right here is sliding this way, right? And at the rate dy dt, and this is what we need to find. So a good sketch is really more than half of the answer. Okay, so again, this is a word problem, so I want to start with given, and then what's given, and then what is it that we need to find? Well, the length is 10 feet. This is given to us. Also, what is given to us is dx dt equals 1 feet per second. And also that x, this is dx dt when x equals 6. So I'm going to write it like so. Okay? To combine these two pieces of information. Dx dt equals 1, but this is true when x equals 6. As we know that the rate is going to change, and what we need to find is dy dt, of course. Right? So, how we tied up x and y? Well, we have a right angle here, assuming that the wall is vertical, which no reason to think that we have a slanted wall or something crazy like that. That the builder who built the wall knows what he's doing, not unlike some builders that I know of. But this is a story for another time. So if that's the case, then we have the Pythagorean theorem in place: x squared plus y squared equals L squared. Okay? And because of that, then we learn also implicit differentiation. So we can differentiate implicitly with respect to, come on guys, with respect to what? What is the variable of differentiation here? T. It's a time. dx dt, dy dt, that's what we're interested in. So, we're going to differentiate this with respect to time. So we have 2x dx dt plus 2y dy dt equals dl dt, but dl dt is simply 0. Right? Actually, this can be written as x squared plus y squared equals 100. I'm sorry, go ahead. But the derivative of 100 is 0. Right? Derivative of a constant. Okay? So from here, we get reduce the y. Remember, this we know this, we want to find this one. So you have, we can reduce the 2, divide everything by 2, and you get y dy dt equals x dx dt, and therefore dy dt equals negative x over y dx dt. And I think we saw this result before. Remember when we learned implicit differentiation, we looked at the circle which has the x squared plus y squared equal r squared. Now, what happened? We need y in order to solve. We know x equals 6, but what is y? Well, y, going back here, y squared equals L squared minus x squared, and therefore y equals the square root of 100 minus 6 squared, and this is 100 minus 36 is 64, so it's equal to 8 feet. And now we are ready to go. You're going to say dy dt when x equals 6 and y equals 8 is equals to negative 6 over 8 dx dt, which is 1, or negative 3/4 feet per second. And that's it. That's the answer, my friend, and the solution to this problem. And I'll give you one more, two more actually, I see, before we go into the next section, which is 3.10. So 2 more examples coming up on Wednesday. I think the homework for this section already open. All right? So be good, be happy. I'll see you on Wednesday.